Stop using that mental math shortcut for energy calculations. Right now. Seriously. You know the exact one I mean. You read an energy transfer question, punch the numbers straight into your calculator without writing down the formula, grab an answer, scribble it on the dotted line, and move on. You probably think you've just saved precious time, right? Well, actually, you've just triggered a massive trap that costs crucial exam marks. Welcome to this explainer. Today, we are exposing the most common Cambridge IGCSE Physics 0625 mistakes that literally drain your score. And we're specifically targeting energy stores, transfers, conservation, work, and power.
Have you ever walked out of a Cambridge IGCSE physics exam feeling like you totally crushed the paper, only to get your results back and realize you missed the next grade boundary by like 2 marks? It is incredibly frustrating. And I'll tell you a secret, 9 times out of 10, it's not because you didn't understand the complex physics. No, it's because of simple, entirely preventable errors in your energy and efficiency answers. You see, the examiner mark schemes are absolutely ruthless when it comes to method marks. If you just write down a final number and it's even slightly off, maybe just a tiny rounding error, you get 0, nothing. But if you write down the formula and the substitution first, you secure those method marks even if your final calculator mashing goes slightly wrong.
Let's look at the actual data here. Ordinary revision usually fails because it focuses purely on memorizing formulas, right? But it completely ignores the fatal traps that examiners are actively hunting for. Consider these 3 fatal revision traps. The first trap? Missing units. Just writing 500 instead of 500 joules instantly loses you the final accuracy mark. The second trap is rounding way too early. If you round your intermediate steps in a kinetic energy calculation, your final answer is going to be completely skewed, and the consequence is a heavily penalized final grade. And the third trap? Vague explanations. Saying something like energy is used up instead of energy is transferred to the thermal store of the surroundings will absolutely cost you the explanation mark. Examiners are literally trained to spot these specific mistakes. Okay, let's dive into this. Here is the exact Cambridge syllabus contents page from our source material. Notice exactly where these traps live. We are zeroing in directly on Chapter 6, Energy Stores and Transfers, specifically Sections 6.1 through 6.4. That covers energy stores, conservation, and energy calculations. And we're combining that with Chapter 8, Work and Power, looking closely at 8.2, Calculating Work Done, and 8.4, Calculating Power. Listen, these 2 chapters form the absolute backbone of the hardest calculation questions in Paper 4. If you can conquer the traps right here, you secure a massive percentage of your overall grade.
Now, in just a moment, I'm going to show you the exact examiner clue that flips a 0-mark calculation into a top band answer instantly. But first, you need the framework that makes that secret clue completely obvious. Because without this framework, you are essentially just guessing what the examiner wants to read. We need to stop thinking like a student taking a test and start thinking like the examiner holding the red pen.
So, here is the foolproof 4-step framework to structure every single Cambridge explanation and calculation. I like to call this the Examiner Whisper Framework. Step 1, state the core concept or equation immediately. Don't hide it, put it right at the top. Step 2, extract the exact evidence or data from the question prompt and substitute it into your equation. Step 3, apply clear scientific reasoning. This is where you explicitly show your intermediate calculation steps without rounding a thing. And Step 4, finalize with examiner wording. This means using the exact syllabus terminology, stating the final value with the correct significant figures, and attaching the standard SI unit. If you follow these 4 steps, you literally force the examiner to give you every available mark. Let's actually apply this to a real exam scenario so you can see it in action.
All right, Section 1. Let's fix a flawed answer using a real exam scenario. This brilliantly illustrates the difference between getting a C and an A star. Notice how the flawed answer on the left simply states, the machine has 500 energy. It uses it to do work, but some is lost as heat. It calculates work done, but gives a raw number without any variables. Ouch! In stark contrast, look at the improved top band answer on the right, applying our framework. The machine has an initial kinetic energy store of 500 joule. Notice the specific terminology and the unit. Work is done against friction, transferring 100 joules to the thermal store of the surroundings. It then explicitly shows the equation, the substituted values, and the final answer with exact units. The right side grabs absolutely all the method and accuracy marks. Let's do a quick red pen critique of that flawed answer through the eyes of our examiner. Number 1, they entirely missed the specific energy store name. Just saying energy isn't good enough. It has to be kinetic energy store or gravitational potential store. Number 2, they rounded the intermediate step, which completely destroyed their final accuracy. Number 3, they omitted the final joules, which is a fatal error.
And number 4, their super vague conclusion about heat being lost is not scientifically supported by the data or standard Cambridge terminology. Remember, energy is transferred, it's never lost. Okay, let's escalate the stakes a bit and move into work and power.
Moving on to Section 2, spot the error as we escalate the stakes.
All right, here is a scenario for you. A student reads a question asking for the power output of a motor. They correctly recall the formula. Power equals energy transferred divided by time taken. Great start. The question states the motor runs for 2 minutes and transfers 1,200 joules of energy. The student writes, power equals 1,200 divided by 2, and gets an answer of 600 watts. So what is the exact penalty for using minutes instead of seconds here?
Hold that thought. Look at your own mental calculation right now. Predict exactly what the examiner is going to write next to that answer. Are they going to give partial credit just for knowing the formula? Will they deduct a single mark? Pause for a second and lock in your prediction before we reveal the examiner's secret.
So the crucial point is right here in the core definition from Chapter 8. Power is the rate at which work is done, which mathematically is energy transferred divided by time in seconds. Standard SI units are totally non-negotiable here. If you divide by 2 minutes instead of 120 seconds, your answer of 600 watts is entirely wrong. The correct answer is 1,200 divided by 120, which is 10 watts. The penalty? Well, if you only wrote the final wrong answer of 600, you score a flat 0. If you wrote the formula down first, you might scrape by with 1 method mark, but you completely lose the substitution and accuracy marks. Time must always be converted to seconds. All right, finally, let's look at the practical checks.
Section 3, the final exam check, specifically for Paper 6. Consider this your mandatory final exam checklist. You have to run every single physics answer through this filter. First up, did I include units for every numerical value? Second, did I verify my significant figures actually match the data given in the question? Third, if I drew a graph, did I check the scale and label the axes with quantities and units? Fourth, have I noted any experimental uncertainties or safety procedures if they asked for them? And finally, does my written conclusion actually match the numerical data I just calculated? Look, if your calculation says efficiency is 120% and you just write it down without thinking, your conclusion is physically impossible. Efficiency literally cannot exceed 100%. Always check your work for reasonableness.
Let this quote really sink in for a moment. A conclusion is only as strong as the data supporting it. If you write a beautiful, eloquent paragraph about how an electric heater works, but your calculated data points contradict your written explanation, the examiner simply cannot give you the marks. Your final answer must logically align with the evidence you just derived. And that brings our 4-step framework full circle, right? Concept, evidence, reasoning, and precise examiner wording.
Okay, so you now have the ultimate framework to secure your energy and power marks. You know the fatal traps, you know to always check your units and your time conversions. But wait, what about specific question type traps? Because honestly, knowing this framework isn't going to save you if you misread a specific command word. If a question clearly says describe and you explain, you are going to get 0 marks, even with absolutely perfect physics knowledge.
That is exactly why your mandatory next step is to master those command words. In our next explainer, we are going to navigate the safe shortcuts for specific question types in Physics 0625. We'll break down exactly what the examiner expects when they say calculate versus determine or describe versus explain. It is an absolute must-watch if you genuinely want to bulletproof your exam technique.
Do not leave your final grade to chance by falling for the simple traps we exposed today. Lock in your revision strategy. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. I'll see you in the next explainer where we decode those tricky command words. Until then, ask yourself, how many marks have you already lost to mental math shortcuts? Keep focused, keep practicing, and go ace those exams.